Mars, a distant world, shrouded in mystery. For centuries, humans have gazed upon its reddish hue in the night sky, dreaming of the day we might set foot on its surface. That day is coming soon. We are on the cusp of a new era of exploration, one that will see humanity establish a permanent presence on another planet. But Mars will not give us a warm welcome. It is a harsh and unforgiving world, a place of extreme temperatures, a thin atmosphere, and constant bombardment from radiation. It will test our limits, push us to the brink, and demand every ounce of our ingenuity and courage. Yet despite the dangers, the allure of Mars is undeniable. We are going to Mars. Imagine stepping out onto the surface of Mars. The first thing that hits you is the cold. Bone-chilling, soul-numbing cold. The average temperature on Mars is about -63 degrees Celsius, or -81 degrees Fahrenheit. That's colder than the coldest temperature ever recorded on Earth. Then there's the atmosphere, or lack thereof. The Martian atmosphere is about 100 times thinner than Earth's, and it's mostly carbon dioxide. You can't breathe on Mars without a spacesuit, and even with a spacesuit you're exposed to dangerous levels of radiation from the sun and cosmic rays. Martian dust, fine as talcum powder, is everywhere and can wreak havoc on equipment. Gravity, only about 38% of Earth's, will have long-term effects on the human body. And the isolation, the sheer distance from Earth, will test the psychological limits of even the most seasoned astronaut. Mars is trying to kill us before we even arrive. So why Mars? Why subject ourselves to such a hostile environment? Why risk everything on a journey to a planet that seems determined to kill us? The answer is simple: because we have to. The survival of our species depends on it. Earth is finite, its resources are limited. We are facing global challenges, climate change, overpopulation, resource depletion, that threaten our very existence. Mars represents an insurance policy, a backup plan for humanity. But it's more than just survival. Mars is a scientific goldmine. It holds clues to the history of our solar system, the formation of planets, and perhaps even the origins of life itself. By studying Mars, we can learn more about our own planet and our place in the universe. And let's not forget the technological advancements. Getting to Mars and building a self-sustaining base will require pushing the boundaries of engineering, robotics, and material science. Getting to Mars is hard. Building a base on Mars is even harder. It's a logistical nightmare, a Rubik's Cube of engineering challenges, and a testament to human stubbornness. First, there's the issue of transporting materials. It takes a lot of stuff to build a base. Habitats, life support systems, power sources, food, water, tools, and everything else needed for humans to survive on a dead planet. Shipping all of that to Mars is going to be incredibly expensive and time-consuming. Then there's the challenge of creating a self-sustaining environment. We can't rely on Earth for supplies forever. We need to find ways to grow our own food, generate our own oxygen, and recycle our own waste. We need to create a closed-loop system that can support human life indefinitely. And let's not forget about the health risks. Radiation exposure, muscle atrophy, bone loss, and the psychological effects of isolation are just a few of the challenges we'll need to overcome. Keeping humans healthy on Mars is going to be a full-time job. The challenges are daunting, but not insurmountable. Section 5. Ingenuity to the rescue. Overcoming the obstacles. The challenges of building a Mars base are real, but so is human ingenuity. We are a species of problem solvers, innovators, and dreamers, and we are already developing the technologies we need to make a Mars base a reality. One promising solution is three-dimensional printing. By using Martian soil as a building material, we can drastically reduce the amount of material we need to transport from Earth. Three-dimensional printers can create habitats, landing pads, and even roads, using nothing but the resources already available on Mars. We are also developing advanced spacesuits that will allow astronauts to work and explore for extended periods in the Martian environment. These suits will be lighter, more flexible, and more comfortable than ever before, and they will be equipped with advanced life support systems and radiation shielding. Robotics and artificial intelligence will play a crucial role in building and maintaining a Mars base. Robots can be used to perform dangerous or repetitive tasks, freeing up astronauts to focus on more complex work. AI can be used to monitor systems, optimize resource allocation, and even assist with scientific research. Section 6. The terraforming debate. Reshaping Mars, or adapting to it. The idea of terraforming Mars, transforming it into a more Earth-like planet, is a captivating one. Imagine a Mars with breathable air, flowing water, and a thriving biosphere. It's a tantalizing vision, but is it realistic, and is it even ethical? Terraforming Mars would be a monumental undertaking, requiring technologies that are currently beyond our reach. It would involve releasing greenhouse gases into the atmosphere to warm the planet, finding ways to thicken the atmosphere, and somehow creating oceans on a planet that has been dry for billions of years. Some argue that instead of trying to reshape Mars in our image, we should focus on adapting to its environment. This means building habitats that can withstand the harsh conditions, developing technologies that allow us to extract resources from the Martian soil and atmosphere, and perhaps even genetically modifying ourselves to better tolerate the low gravity and radiation. The terraforming debate is complex, with valid arguments on both sides. Section 7. Ethical Considerations, Treading Carefully on a New World. As we venture further into the cosmos and contemplate establishing a permanent presence on Mars, we must proceed with caution and a deep sense of responsibility. The colonization of Mars is not simply an engineering challenge, it is an ethical one, demanding careful consideration of our actions and their potential consequences. One critical question is whether we have the right to claim another planet as our own. Mars is not a blank slate. It has its own history, its own geology, and perhaps even its own microbial life. Do we have the right to potentially disrupt or destroy what is already there in pursuit of our own goals? Another ethical concern is the potential for exploitation. As we begin to extract resources from Mars, we must ensure that we do so in a sustainable and equitable manner. We must avoid repeating the mistakes we have made on Earth, where greed and short-sightedness have led to environmental degradation and social injustice. The colonization of Mars also raises questions about governance and decision-making. Section 8. A Giant Leap for Humanity, The Significance of Mars. The journey to Mars is more than just a scientific endeavor or a technological challenge. It is a defining moment for humanity. It is an opportunity to redefine what it means to be human, to push the boundaries of our knowledge and capabilities, and to secure a future for our species among the stars. By establishing a permanent presence on Mars, we will be taking a giant leap forward as a species. We will be proving that we are capable of overcoming even the most daunting challenges, that we are not bound by the limits of our own planet, and that we have the potential to achieve greatness beyond our wildest dreams. The knowledge we gain from exploring Mars will be invaluable. By studying its geology, its atmosphere, and its potential for life, we will gain a deeper understanding of our own planet and the processes that have shaped our solar system. We may even uncover clues to the origins of life itself, answering one of the most profound questions that has ever haunted humanity. The technological advancements required to get to Mars and build a self-sustaining base will have far-reaching implications. They will lead to new industries, new jobs, and new solutions to problems here on Earth. The pursuit of space exploration has always been a driver of innovation, and the Mars mission will be no exception. But perhaps the most significant aspect of the Mars mission is the inspiration it will provide. Section 9. Inspiring Generations. The Mars Mission as a Beacon of Hope. The Mars mission is not just about reaching a distant planet, it's about reaching for a brighter future. In a world often consumed by division, conflict, and uncertainty, the pursuit of space exploration offers a beacon of hope, a shared dream that transcends borders, cultures, and ideologies. When we look up at the night sky and see Mars shining brightly, let it be a reminder of our shared humanity, our boundless potential, and our unwavering spirit of exploration. Let it be a call to action, an inspiration to work together to solve the challenges facing our planet and to create a better future for all humankind. The Mars mission is a testament to the power of human ingenuity, resilience, and collaboration. It is a story that will be told for generations to come, inspiring countless others to reach for the stars and to make their own mark on the universe.